Okay, hello everyone. Thank you for the introduction. I'm Gimena Casaretto from the University of Buenos Aires, and I will be presenting the Ensemble Forecast Sensitivity to Observation Impact applied to a regional data simulation system over Argentina to see the influence of thermodynamic GOES-16 retrievals. This is part of my thesis work of my PhD student in the National Weather Service of Argentina and the University of Buenos Aires. The presentation will be structured as follows. First, I will talk about the motivation. Then I will talk about the data that we'll be using, the case study, the data simulation setup, the impact studies that we carry out with EFSOI, and summary and conclusions. First of all, the motivation is, as you can see in this figure, this is the southern South America, the Argentinian region, where we have only 9 sounding locations that are the small stars in the region. Currently, the National Weather Service does not have enough computational and human resources to be able to assimilate radiances. So we do have the data simulation system prepared to assimilate the temperature and humidity profiles. That's why we want to study the performance over Argentina with the all-two soundings available, and also the impact of assimilating them in a convection-permitting regional system. Previous studies, we have already shown positive impact of the Earth's all-two retrievals being included in this region. So the satellite data that we use is temperature and humidity from EASI, the European METOP satellite series, NUCAPS from the Joint Polar Satellite System, ERS from the NASA Aquapolar Orbiting Satellite, and GOES, the ones from GOES-R. So the data simulation setup, we use a local ensemble transport Kalman's filter coupled with the weather research and forecasting. We took a 4-kilometer horizontal resolution and 60 vertical levels, 40 ensemble members, boundary conditions of the GFS combined with the GEFS, and we use a multi-physics scheme with different parameterizations. We obtain hourly analysis between the 13th of December 19 UTC to the 14th of December 18 UTC. 3 experiments were conducted in that region and using different observations. The case study that we used was a mesoscale convective system that was developed over the central region of Argentina, and 2 relampago missions were conducted in that area. So, in experiment 1, we assimilated ERS observation, EASI, and NUCAPS. In this first figure to the left, you can see the spatial distribution where ERS observations cover most of the region, while the EASI and NUCAPS are more sparse. Then in the right figure, we can see the time frequency of the observation assimilation, and we can see that we have the 25 cycles, and we can see that there are a lot of cycles without observation and a lot of cycles where the satellite observations overlap. In this second experiment, we added the GOES observations. In this case, we can see that the GOES has a lot of frequency, spatial and temporally, more than the other satellite. And lastly, we carry out the experiment number 3, where we had all the observations available, which were automatic surface weather stations, conventional surface weather station, soundings, radar, airplanes, GOES motion vectors, EASI, NUCAPS, and the GOES temperature profilers. So, what were the impact studies that we carry out? We used the EFSOI technique, that is an objective quantification of the impact of each assimilated observation. The difference between the errors of the forecast initialized from the analysis with the assimilated observation versus the forecast without that assimilated observations. As you can see here in this, I don't have that, there it goes. As you can see here in this sketch. So the difference between these two forecasts is the observation assimilated here. EFSOI was calculated for 1 hour and 6 hour evaluation forecast time. So a negative quantitative indicates a beneficial observation. It's the reduction of the forecast error. A positive quantitative indicates a detrimental observation, a magnification of the forecast error. We obtain the beneficial impact rate, that is the amount of observations that resulted beneficial over the total amount of observations. So in the first result here, we have histograms where we have first the positive impact rate for the 3 experiments. First for experiment 1, then for experiment 2, and lastly for experiment 3. Here we can see that NUCAPs have a beneficial impact rate superior to 50% for the 3 experiments. YASI had the lower impact as other observations are assimilated, and the GOAS observations have superior to 50% beneficial impact rate and a larger number of observations assimilated in all the cycles. Then for 6 hours evaluation forecast times, we can see that the percentages decrease if you compare these two figures, and that YASI in this case obtained values superior to 50% for all the 3 experiments. NUCAPs, on the other hand, has for longer forecast times the beneficial impact rate underneath 50%. ERR's impact was better in the experiments with more observations than the previous experiments. Lastly, the GOES sounder profiles maintain the same values for the 3 experiments. Then to do a further study, we did the profile beneficial impact rates. So here we have only presented for experiment 1 and experiment 3. In this case, we see the distribution of the beneficial impact rate accordingly to the lever pressure. In this case, we can see that in the first experiment, ERRS has a steady percentage around 60-75%, while NUCAPs also has a good percentage, and ERRS has the worst values compared to, YASI has the worst values compared to ERRS and NUCAPs. Then we have compared to all the, when you have in experiment 3, all the observations, clearly YASI has the worst values, they're all red, so it's beneath 50%, and the profilers decrease when other observations are included. More sensitivity experiments should be carried out, so for example, superoving. Then for 6-hour evaluation forecast time, the beneficial impact rate decreases compared to the 1 hour, and for the ERRS and NUCAPs. NUCAPs, ERRS, and YASI have been similar when other observations were added for longer forecast times. As summary and conclusions, YASI, NUCAPs, and GOAS, all 2 retrievals, were successfully assimilated in a high-resolution numerical weather prediction model for a case study. More observations are needed to improve the data simulation system and enhance the impact of all 2 soundings. GOES 16 have a higher amount of observations and impact. NUCAPs and ERRS have broader impacts compared to YASI in 1-hour evaluation forecast time, but for 6-hour evaluation forecast time, the other way around. Larger amount of observations assimilated, all 2 soundings compared to the common soundings. Soundings values, radio zones, are of positive impact were slightly higher than the all 2 soundings, but smaller amount of observations. This confirms also the great value of continuum launching radio zones. Lastly, more sensitivity experiments exploring, for example, the superoving and the localization parameters for all 2 retrievals should be considered to improve their impact in data simulation. Thank you very much for your attention.